So obviously I don't want to go making something like a Gucci carbon mast for races or something like that, but I do want to make something. So I've come to Hungary. I've come to probably the most innovative brand that I know of in carbon manufacturing sailing. These guys make boats, they make masts, they make booms, they make rigging. That's a bit that holds the mast up as well. So basically I'm coming to steal a few tricks from the trade from these guys and learn exactly how they make masts and basically how I can steal some ideas to do it myself. So I know that the man that I need is in here. Jenny's already mic'd him up. If I can see him right there. Ballint! Let me introduce you to my friends here. Hello,
Hi,
mate.
Chris, how are you?
I'm alright, mate. How are you?
It's good to see you. Yeah, I'm fine.
Good to see you, man. Good to see you, bud.
Yeah.
So Ballint's basically the fella who oversees the entire production here. And it's pretty cool.
Yes, more specifically, it's the mass production.
Oh, you do that, right? Okay.
Yeah, I'm responsible for. It's a family-run company. My father started it in the 1990s, and since then me and my brother joined him.
Yeah.
And now we are building carbon spars and high-performance carbon sailboats.
Like when he says like high performance, he means like the sort of the top tier, you know, like IMOCAs.
Yeah,
and the foiling ones, the flying boats.
Yeah, the flying. Let's say flying IMOCAs. We did some in the past years.
Yeah. So that's pretty cool. And so basically today we're going to take a walk around the factory. I've convinced him to take us around, and we're going to learn little bits about how technical it gets in there. All the technical stuff we'll do on Sail Hub and all that stuff. But basically today we're going to take a wander around and see how they make carbon fiber masts. I'm going to steal some ideas off you, mate.
Yeah.
And see if I can make myself an indestructible carbon mast to take me to the Patagonia.
Yeah, and which is still light and stiff. Yeah.
Well, that's the idea, yeah. I want it to work. I want it to perform.
Yeah, of course, that's the idea. So, okay. So why don't we start with lamination?
Come on, man.
Okay, let's go.
I'm going this way.
Just after you.
All right, so we're into the meat and gravy right now, guys. This is an RC44 yacht here. This is fully carbon. They've got another one hidden over here somewhere. Can you see that? Absolutely insane. And Ballint's about to take me. Where you take me, mate?
I'm taking you where we do the lamination of the carbon masts.
So this is it. This is where it all happens. So a lot for me to learn here. Tripping over. A lot for me to learn here if I was going to be doing something like this. So what we got, mate?
Yeah. So first we got here so-called pre-preg, which is carbon fibers impregnated with resin. And then that's why it's very good, because the content of the carbon fiber and the resin is very exact. So, and we get these in rolls. Like
it's a
this.
nice roll he's got there, isn't it?
Yeah, so
the razors
here,
and all sorts. What's going on here, man?
so here we have a mast built for a 40-footer racer, lake racer.
How long is this mast?
This mast is about 21 meter long.
So basically this is the same size boat as what we have, but the mast is colossal. You can do that because it's lighter though.
Yes, yes.
So you were telling me.
First the guys lay the base layers, which gives the core strength of the mast.
Right, okay.
Core strength and core stiffness.
Yeah. So that's what I'm looking at here. These sort of longitudinal fibers. This is the core strength, and then you put some reinforcement patches here, some fiberglass here, which gives it a bit more flex.
So 90-degree fibers and plus minus 45-degree fibers.
So if I was going to build my own carbon mast, you might say just put loads of them in as well, because I'm probably not going to laminate it very well.
Yes, I mean, if you will do that, but I won't give you a warranty. I hope you understand that. Yeah. If the mast is made by you.
But what's going on down here anyway? There's so many bits. Walk me through what's going on. So this is a spreader.
No, this is the forestay fitting. This is the reinforcement for the forestay fitting.
Yeah.
And here you have reinforcement for the runner attachments.
Right, so this is where the halyard's coming up.
Yes.
That's a rope for people who don't know. Okay, so we'll put a sheave box on there. That's a fancy sailor's name for a pulley. So that's where the...
Yes.
Okay, and that's a long way to the top of the mast.
So this mast has 3 spreaders.
So,
And this is the third one.
Do you know what it is, right? The amount of engineering that goes into this, like starting with the computers, that's one thing. Getting the brains to actually design the mast so strong enough. Program it. make the tooling. And this tooling is insane. I can see it. It's around me. It's massive.
So far we've got the core strength laid down, and using the lasers we get the strengthener patches where they're supposed to be on the inside of the mast. Now the moulds are closed and a big bag is put inside. This bag is inflated to 4 times the pressure of conventional vacuum techniques, which achieves a stronger void-free lamination. The next step is to cure the resin in a massive oven. This bonds the overlapping sides of the mast together permanently. When she comes out, we're left with a smooth and strong mast with no visible patches.
Yeah, I mean, these are things you don't normally see. I mean, people just see like a tube and they're like, oh, look, it's just a tube. But it's not.
Yes, it's
a tube with bits in it.
Yeah, you put you put strength where you need it.
And I guess that's the thing. So, as with everything that we're learning about the mast, it's like, it's about where the weight is positioned, not just the overall weight loss. And so what you're saying here is all the strengthening is put where it's required and not where it's not. So it's not like just a thick tube. Like aluminium, if you need to get a stronger mast, your only option is to go up a section in size and then the whole tube gets heavy.
Yes, I mean from top to bottom you will have an even weight per meter with an aluminium mast.
Yeah.
And on average you can say that the carbon mast for the same stiffness is 40-50% lighter than the aluminium one.
The engineering is fantastic, and what I like about it the best is you're still using parcel tape.
Parcel tape. Yeah,
parcel tape is
I mean,
and people laughed at me for using parcel tape, and look at that. Here are the pros doing it.
Yeah, I mean,
works, doesn't it?
If it works, you use it.
Yeah,
That's
there
it.
we go. All right, cool. So let's go on to the next part then.
Okay, next part is what do you want next?
Thanks, mate. Spreaders. At least that looks like a spread, yeah.
So you just seen that we have local reinforcement and all kind of patches for the spreader locations on the mast.
Yeah.
And we basically do the spreaders the same way as we build the mast.
Cool. So that's like an airplane wing, isn't it? And
Yeah, that's the idea.
That's the idea, yeah. So it just reduces the loss. That's mad. So this is cut out with, like if I was going to make this up, oh, it's sharp.
Be careful.
Oh, it's a bit late to tell me now, isn't it? So,
I won't take you to
gonna-
the hospital, so be careful.
cut my thumb. No, I haven't. So, if I was going to make this myself, I'd be cutting this out with a grinder, a cutting disc. You're presuming, like looking at how neatly this is done. How do you, this is done with a computer, is it?
Yes, it's because as you see, this is how it comes out from the tooling.
Yeah.
So it's it needs to be cut, as you said, and we have a CNC machine, a 5-axis CNC machine, which makes the cutouts, and each spreader needs to be cut differently because each mast has a different spreader's sweep angle.
Yeah. Yeah.
Meaning
So that's the angle that it comes back on the boat. So for anyone who doesn't know, basically a spreader, what it does, it's like, some people call them cross trees, you hear all sorts of weird names, but basically they're the bits that come out the side of the mast like this, and the rig is supported by it. So you need strong spreaders, because as the wires get tight, if they're not very strong, they buckle and bend, right?
Yes,
But they basically the rig holds up the mast, but it also allows you to build a lighter mast if it's got a strong rig. And this is part of that.
yes, it's part of that.
I like this one because it's got a beer cup in the end of it. So I can have like this, put my beer in there.
Yes, you just that's a holder for your beer. That's it.
So sometimes you got wire goes through the end like this. This one here is made to take the wire through the end, or the rod rigging or whatever it is. And this one's got something called, I can see that, there's a tip cup there, look.
Yeah.
So this tip cup has fancy rigging. This is a one too small, but it sits in there like that, right?
Yes, exactly. It's designed to accept the tip cup.
I like that. I like this idea. This is the kind of thing I'd like to build.
Yeah, so very briefly, this is how it comes out from the tooling.
Mm-hmm.
This is a CNC machine piece,
Yeah.
and this is the painted one.
So you can paint it like that, or you can varnish it like that.
Yes, you can keep it as varnished, or you can paint it.
And this is the vang, right? This is the bit that holds the boom up.
Yeah, that's the boom vang, and it has
Super light. Yeah.
this is the raft piece, and this one goes through CNC machining also, and then we just varnish it.
That's crazy, isn't it? The difference between that and that, but it's the same thing. That's so sharp.
Yeah.
Cool. So this obviously fits on using these metal brackets. Spreaders normally have some kind of aluminium in there. I can see one there. So is that something you buy that in and then you stick that in the mast? Because this, obviously we've got to fit these to the mast, right?
Yes. That's the spreader through bar.
And that goes through here.
It goes through here and it's fixed. The bar is fixed to the spreader via pins.
Yep.
And this is also CNC machined for the right angle. And it's not just about the sweep angle. It's also about the lift.
Yeah. That's to spread the weight evenly. As the mast goes up, the cables go up and then they come in. As they go in, that angle needs to be basically equal over that one.
Yes. So that's
Cool.
also engineered. And we make all these parts in-house.
It's looking like it's pretty difficult for me to make my own mast now.
Yeah, I mean, you would need some CNC machines and.
So these are, again, these are where
the.
there's like diagonals in here as well. Like, so you'll see on these masts that are laid up, like you have different levels of spreaders, and then you have a piece of rigging goes through the spreader and down to the next spreader on an angle like that. And that's machined with a tip cup in there, isn't it?
Yes, that's machine. Everything is machine. This is like sculptured out from the tomb.
Yeah. My grandfather was a wood carver. It's the same thing, mate. He didn't need computers though.
Yeah, so,
He's good with his hands, mate. You know how he is.
Yeah, so maybe you can do it for yourself. It's,
Probably. It's take me a little while. But you know, I've only got like 2 to make for the boat, so maybe it's worth it.
we have a lot of custom milled stuff, and let me show you, for example, what this is exactly.
Okay.
Let's go.
Let's go. Boom.
Yeah.
When it comes to finishing the boom, everything is done completely and utterly by hand. The meticulous finishing process starts as soon as it comes out the mold. Sure, it goes through CNC and one thing or another to get its shapes and all of its hardware fitted, but it's the handwork that actually makes the difference. Once it's finished and almost ready for paint, the mast actually gets assembled 100% to make sure it works well before the paint starts. Several coats of polyurethane go on here, one of the most robust punch you could ever imagine, and multiple coats go on both the mast, the boom and the spreaders. These guys are looking for robust durability so it can withstand anything that the ocean is going to throw at it.
So, normally you get this piece with a small stand,
Yeah.
but that stand has like this size. A pair of flip-flop blocks.
Very technical, isn't it?
Just a sec.
What he's trying to say is,
Yeah.
those pulleys are usually like, they've got one like fancy big block either side and they won't fit in. So he's machined this piece up completely to fit into the boom. And what this does is it controls the boom as it goes from left to right. There's a rope comes down and out of here, but you've machined this piece specifically for this boom.
Yes.
And I can see around like here is like,
Yeah.
you've got spin lock ones on there, like totally, they're all different, aren't they?
Yes, we custom
All
make
different.
the solutions to fit what the customer needs.
Can see right through the other end. That's the kind of thing that tickles my fancy. So you do these in like, can you have them in any colour you want? Or?
Yeah, any color you want. Yeah. You're thinking about a pink one or what?
Maybe. That's for you before I drop it, my
thanks.
friend. Okay, cool. These guys here are fitting spreaders.
Yes.
Can we watch them put one on?
Yeah.
I put spreaders on before,
they
but I haven't
already-
actually put carbon ones on.
Yeah, they already put one on, so
This is the bit of rigging I was telling you about before. Is that titanium?
yeah, that's titanium because
Weighs nothing.
this mast will be fitted carbon standing rigging, and for carbon standing rigging we use titanium fittings. So
Sorry, I'm taking the party's word, but that weighs nothing.
yeah,
Sorry,
I mean titanium is 40% lighter than stainless.
yeah.
So yeah,
I once watched a fella put a mast on, and he put all the, because these are angled down over or up over, depending on the boat, not how it works, but he put them all on upside down.
Oh.
He did. All upside down. They stepped the mast, and the rig didn't fit, and then take it all back off again and step them the other way around. It was a funniest thing.
Yeah, and I can imagine he was complaining about the rigging, the cable lengths are not right because you know the spreader was pointing downwards.
Exactly, yeah. And yeah, he didn't get any more jobs, that fella.
Yes.
Cool.
So you just slide the spreader on, and then you have these holes for the fixing pins.
And is this a track that's, do you make this track? Is this bolt-in track? Do you bolt it? It's a bolted track, I see that.
Yes, we always try to use mainsail tracks which are both bolted and bonded
Bolt and
for
bond.
maximum security.
Belt and braces. I saw on, was it one of the Mocha race teams on the last round of the world race, one of their masts, one of the tracks started to come off halfway through. That was the end of
Yeah, I
that.
mean in extreme cases you have some high load areas.
Yeah, but I think that was just a bonded one, there was no bolt.
Yeah.
So yeah, belt and braces.
So we will bond and also bolt yours. I mean the track of your mast on your mast will be bonded and bolted.
It
for
will
sure.
be? Okay, mate. I'll take your word for that. Can you show me how you make these?
Yes,
That was easy. Yes.
why not?
Fantastic. Look at the size of this mill. Mental. Ballint, what's this?
No, explain that. And this one.
Some piece of machine at that. That's like a... Is this a mast base?
Yeah.
Yeah. Big, isn't it?
Yeah.
What's this for?
Neo 520, but it will have a bunch of sheaves attached to it.
Yeah.
And this is custom made,
Yeah.
so you need the right geometry. You have to consider the forces. So you have to engineer a new plate, and we do that.
You're making me nervous, Ballint. I've got to go through all this in my boat. I don't have an engineering team like you. I have like May and Jenny. Jenny's actually really good at that.
Maybe we can help you out on Sundays or something.
On Sundays. Okay, so we need to go and see the next bit.
Yeah.
What's the next bit you do? So you've machined it, you've got all the parts, rig.
Rig, yeah.
I'm excited about this.
Yeah.
This is one of the cool bits because like
Yeah,
rigging's normally boring. It's wire, but again, because we do everything in house as carbon, it's
that's
gonna be carbon, isn't
more
it?
exciting.
Is it?
So let's go. After you.
right. Back here again, mate. Back here.
Back here again at the carbon standing rigging. This is a complete set for a 52 volt
Totally carbon, 100% carbon.
100% carbon, yes.
Wow. So basically, carbon rigging, what that actually means is it's going to be super light. It'll allow us to sail in lighter winds. It would basically mean there's less weight up the top. So you get less pitching and rolling and forwards and backwards, so you feel less sick.
Yeah.
And again, you get better power transfer, so you can
Yeah,
basically-
lighter and stiffer. Much better.
And it should be a lot lighter. What's this one off? What's this set? Is this a full set of rigging for a boat?
Yeah, full set lateral
Yeah, I
rigging.
thought so, yeah. And so this is for what kind of boat?
This is for a Neo 52 Italian boat,
Right.
racer cruiser.
So like I've lifted this kind of stuff, that weighs nothing. That weighs nothing.
Yeah.
Like normally 52 feet, when I've rigged that, you carry like 2 or 3 rolls to the boat, then you come back for the other 2. This way, what does
Yeah,
this actually weigh?
Well, let's check.
Right then.
Okay.
I can't believe I'm walking around with 52-foot boats, entire rig on my shoulder. I'm holding it with my chin. That's mental. Ballint, I don't want to scratch that boat.
Yeah.
Has this got titanium bits on the end of it?
Yeah, it's a stiff one. So
Has this one got titanium on the end of this?
yeah, it's all titanium.
All titanium. Yeah, it's all titanium. It's just another day in the life for him, isn't it?
Yep.
I'm rubbernecking. I've seen some bits. Alrighty. I've got myself in a position. My belly's too big to fit through here.
Yeah, give it to me and
Yeah,
check.
okay. Let me just check one thing first.
Yeah.
That these are on 0. Lift it up, lads.
You
Go
can
on.
take my word.
I'm not taking your word for anything.
Okay, so let's lift it.
I can't even read it.
You can't even read it.
No.
Yeah, because it's
0, 0. So it's 0, right?
It starts
Okay.
from minus 20. Yeah. Okay,
Okay.
so 0, can you see it?
Yep, it's 0.
Okay. Let's put it down.
I can't read that though. No, I can't read that.
You can read that?
I'm not tall enough. That's gym strength.
Me neither.
for you. See that? Gym strength right there.
8.8.
8 kilograms.
Yeah. 8 kilos.
8 kilograms for the entire rig. I mean, what's it normally weigh? How much lighter is that than normal rigging?
So the cable itself is 80% lighter than Nitronic.
And the fittings are titanium as
Yeah,
well.
and you also have to consider that there are already some titanium turnbuckle bodies on the D2 and the D3.
You can consider
So
whatever
that's-
he's talking about, but that is ridiculous. Sorry, mate. I don't mean to be rude, but that is just ridiculously like 8 kilos. Like that's mental. I mean, that should be like 60 something kilograms.
That should be illegal.
Amazing, mate. Amazing. So it turns out that there was actually 4 cables missing, and this is 2 of them. So the reality is it's actually 5 kilos heavier than that, which is still ridiculously light. Let's put it into perspective that most rigs like that of this size would probably weigh over 80 kilograms. So yeah, anyway, back where we were. Don't break it, Chris. Amazing, mate, amazing.
That's good.
That's amazing. So we're going to go into all that techie stuff on that on Sailboat, to be honest with you, which is going to be really, really cool. I'm looking forward to finding out more about that stuff. Do you reckon that would work in the Arctic then?
On the Arctic?
Yeah. Like I could take that boat to the Patagonia or the Arctic to icebergs.
Yeah, of course you could, and it's very beneficial because you keep weight down, and if you hit an big
Iceberg, yeah.
iceberg or something, then it will not shock the boat as much because it's
Oh yeah,
lighter.
because you got this inertia. Yeah, I thought about
Yeah.
that. I wasn't really thinking about that because when you said I can save weight, I'm just thinking I can carry more bottles of rum.
Yeah, more rum, you don't need to lose weight.
Fantastic.
And you can use less fuel, or electricity if you have an electric engine.
Well, that's the thing, isn't it? That is the thing. Right, okay, so you've got the rig. We need to put that on the mast nest, dress it, and so we've already seen that in there. You've got loads of titanium bits and all sorts of things like that. Should we pop this back on the racks? And,
Yeah, this is complete titanium with carbon.
I can't believe that weighs 8 kilograms. That's blown my mind. Like, I knew it's light, Ballint, but like 8 kilograms light's just taking the mick.
Yeah.
And I noticed, as we went past, I noticed all these bits as well. So these are the tip cups that we looked at before. And basically, they're all going to screw into these.
Yeah,
As you-
discontinuous rigging.
So you guys, how many people fit this out when it's getting dressed, as we call it?
What do you mean by put the rigging on or what?
Yeah, when it's doing, how many people in the team do this?
I mean, it really depends.
You can do it by
I mean,
yourself, I know.
Yeah, one person can do it. It's just faster if two does it. And this is a titanium tip cup. So also with the tip cup you save tremendous weight compared to a stainless one. So for this
So you don't use any aluminium then?
no, for this mast we really went all out because they really wanted this Neo 520 to be high performance, and we were going all out, all high modulus mast, complete titanium fittings, and
So I'll go all out with my mast when I make it, because that means I can carry more rum.
yeah, good point.
Magic, mate. So that's basically the whole thing then. Once you've done that, you take the spreaders back off and send it on the truck.
Yeah.
Cool. Well, there you go. Ins and outs of how Pauger make masts. I certainly learned a lot when it came to the likes of, you know, how it was laminated and stuff like that. Now, I'm no stranger to carbon and I'm no stranger to rigging, but I'm absolutely blown away by a lot of the cool stuff that I've learned here. And a lot of tips and tricks in the customization that you've managed to achieve in this is just like fantastic. So we're going to do all the geeky stuff on SailHub. I'm going to pick Ballint's brains and like learn as much as I possibly can. And yeah, next with the Ghostship, we're going to go and look into where what I learned for this and how, well, I'm not really sure what I'm going to do with the Ghostship, to be quite honest. My mind's a little bit bent at the moment, but do like, do subscribe. And if you want to know more about Pauger, or check out the videos on SailHub, or speak to Ballint in person. Ballint, mate, thanks, man.
Yeah,
this has been class, man.
Thanks,
Like,
it's a pleasure.
like, I can't believe it. Like, just cool stuff everywhere.
Yeah,
Thanks,
thank you. I'm happy that you like it.
You do, yeah. All right,
Okay,
till next
good.
time.